So this is the after lunch slot, so you're all dozy. It's really nice and warm in here, so you're all doubly dozy. So I'm going to do whatever I can to try and keep you awake. And that will involve you having to participate at moments, not the whole time, and I won't make you do any exercise. This session is called Lies, Damn Lies and Estimates. I'm sure it's the title that brought you along. Before I start, I would like to remind you that there is a feedback process that they've asked us to get you to participate in. You can do that on the app on your phone, or if you haven't got the app on your phone, there's a URL in the brochure, so you can go there after the session and say how wonderful it was. So the session is Lies, Damn Lies and Estimates. Can anyone hazard a guess what inspired me or how I was inspired to choose this title? Well, so apart from the estimates, so yeah, do you know who said that? Oh dear, my gag isn't going to work if no one knows what the answer is. No, it wasn't Churchill, I'm afraid. But nor was it so it's attributed to Disraeli. But it's not. Disraeli didn't do it. So it's inspired by Disraeli, and Disraeli actually was attributed as saying the lies, damn lies, and statistics. And he had an opinion that statistics were used basically just to justify anybody's argument, and that they were quite often baseless. And I hope to draw an analogy between them and estimates during this session. So let's start off at the beginning. Well, maybe not right at the very beginning, but let's start off a long time ago. Did the Pharaoh ask his builders for estimates? Seems unlikely, you know. I'm not sure that they had much in the way of cost control. I think basically Pharaoh said, "You're going to build it for me, whatever." And they were prepared to put in a lot of time over it. They were prepared to let people die. Essentially, they just kept on building until either it was finished and they were happy, or they died and got put inside what was there already, or they ran out of money. And the same procedure was used throughout the Middle Ages. You know, building churches and cathedrals. You'd start, someone would collect a bit of money, and they'd start building the church and the cathedral. You weren't holding people to budgets. I mean, people got burnt from time to time, but not because they slipped a deadline or dropped scope. And, you know, people were trained on the job. They spent their whole lives building a cathedral. Occasionally they'd run out of money, they'd stop, there'd be a war, then they'd start again, and they'd build it up. And they were basically working to an order, to the customer specification, which may change over time. But they weren't asked for estimates at the beginning. And what was delivered in the end, you know, they're still World Heritage sites that people visit. You know, they're good things. So I'm not suggesting that we're building pyramids or cathedrals, but I just want us to ground ourselves on where do estimates come from? When did they start being used? What was their purpose? So the pyramids, I don't believe the Pharaoh asked for any estimates. We've certainly not seen any papyrus evidence of that. However, has anyone done a self-build project? Has anyone ever engaged a builder? Right. So did you get an estimate? Why did you get that estimate? Yeah.
You need to know when you can answer.
So has anyone ever watched Grand Designs? How often do they enter when their estimate said they were going to enter? How often do they stay within their budget? Really, really rarely. In fact, I don't think I've ever seen an episode where that happened. And you might say, well, that's because they're grand designs. But actually, the same is true of any self-build project. The only projects that actually come in on time and on budget are the ones where your machine churning out a whole estate, which is just like another whole estate that they've done somewhere else. So a lot of people will say that, you know, software people grow up. Everyone else can do estimates. And the truth is everyone else does estimates, but they do them just as badly as us. So the first thing I want us to agree on, or at least have a think about, is that estimation is a task that humans find very difficult. And it's not just us that are really bad at it. And on another level, the software that we're building is orders of magnitude more complex than any building project. It's more complex than most engineering projects. But there's nothing tangible for people to see, and they just often fail to grasp that there are an awful lot of moving parts in a piece of software, And those moving parts change much more regularly than the parts of a battleship or of a mobile phone. So actually just even comparing them is a problem. So we're not building houses either. But so let's have a look. I wonder if I can get this light a bit dimmer. Does anyone know if the front light dims a bit? Or even more if that's possible. No, that's good. Perfect, thank you. Cheers. So this is an example of a builder's estimate. So the thing about this estimate is it's quite vague. You know, it says a few of the tasks that we're going to fulfill, and it's got some large prices at the end that talk about that essentially give a choice, or at least the illusion of choice to the customer. They can choose between old tiles or new tiles, but we don't know how this price breaks down. And this is quite often the sort of estimate you'll get. You want a job done, it's going to cost you X amount of pounds, and we're vaguely going to do this. Here's a more detailed sort of estimate where it breaks it down into the actual items that are going to be delivered. It's, you know, I'm aware that text is quite small, but it's not, I guess, that interesting. It's just that they're trying to give you the detail of it, so you feel like you have a choice, that you can go in and fiddle with bits and say, actually, can we try and make this one a bit cheaper? So maybe the tiling at £810 is too much. And here's a further one, which is again, a vague one, which is a whole list of, well, it's not quite specifications, but it is promises of what we're going to do in the work. And at the bottom, there's a price. Now, are these estimates? Are they quotes? Are they guaranteed? All of these things are not clear here. Typically what happens, if you've never engaged a builder, I'll let you in on a few secrets. The builders all come, they look at the job, they go away, they give you a quote. You pick the one, typically the one with the lowest price, and that's often not the price that you pay in the end. The work they do may not be to the quality that you were expecting. They may find work that they need to do that they didn't originally quote for. It's like a request for change will come through, and the price will go up. And it continues on and on like that. And they have many techniques for doing this. So, for instance, the builders will come up with things like, I'll be back tomorrow to finish off. So this is a typical way of trying to get you to commit a little bit more resources or money to the project, because they've got you. You'll be in by Christmas is your standard one on Grand Designs. It's your standard one for most builders. We're going to fix this before we leave. This is, we broke something, we got something dirty, we damaged your hedges on the way in. This is a lot like, I'll write the tests next iteration. This will work in the next release. Our previous customers are completely satisfied. So when you work in an IT department, your customers know you, and you'll probably know if they're generally satisfied. If you work by going out to try and sell your services to other people to develop software for them, they will probably try and check up on a few references. But in general, previous review, past performance is no prediction or predictor of future performance. And the same goes with builders. We don't make mistakes like other builders. So this is what ThoughtWorks and other very well-known consultancies will tell you. We're big, we're expensive because we're good. All the people you've been dealing with before have let you down, but we won't. And finally, you won't notice that we're there. And this is we're going to do whatever you want. There'll be lightweight work going on. There'll be a seamless migration from your old system to your new system. Your customers will be delighted. You won't even know that you've been through a development process. Do you think any of these claims are true from builders? Do you think any of these claims are true of software development teams? Thinking. Okay. So I see this all the time. I very rarely find any evidence that this is the case. However, we still got to start off needing estimates. And why do we need estimates? Well, your company needs estimates. What sort of estimates do they want? Why do your companies need estimates?
Because there is some hardware and you must be on time with the hardware.
So that's a delivery estimate. We're going to arrive at a particular schedule. Okay, any others? Cost, yeah. So why do they want to know how much it's going to cost? Sorry? So the client wants to know how much it's going to cost, and what do they do with that price? How do they use it? Yep, we do have the discrepancy between selling an external service and doing something internally. So typically internally there's a fixed budget that has been argued over 12 months ago for software development from the IT shop, and we use budget as part of the inputs of prioritization. When you're going out to sell your services as an external one, quite often it's not so much prioritization. There will be a shopping around of features and costs that people will do to decide whether you're the right person to go ahead. But most people who go into that, well, we'll deal with that in a wee while. So your company needs estimates. The thing about estimates is they want you to do them really quite quickly. So the idea of an estimate is that it's a cheap thing. You know, they come to you, they say, how much is it going to cost to do this work? If it's easy to do this work, this estimate, then it's easy to provide an estimate, and then you can move in and tout your business to lots of people. If estimates themselves become expensive, then the whole position changes. So I've seen, certainly in IT departments, the process of estimation being gone around over and over again, things being broken down to very small detail, very large pieces of work, you know, with costs in tens or hundreds of thousands of pounds, just to estimate what the project might take, only to deliver an estimate itself that was unreliable and unjustifiable. Yet, this is what we're being asked to do, and typically we're being asked to do it without that large investment up front. They want the estimate soon, they want the estimate now. Frequently, you're getting asked for the estimate yesterday, because you know we've got this budget, we've got to spend it now before the end of the year. How much is it going to cost? And really, it's just a question. They're trying to shift the risk of the investment from the business trying to work out what the benefit is and what the cost is, down to the development department asking you to really put your, you know, not wanting to offend anyone, but to put your arse on the line by saying this is when it'll be ready, this is how much it's going to cost, so that when finally it gets delivered, if it doesn't deliver the benefits that they thought it was going to, it's not their fault. Now, how often when you get asked to give an estimate, do they also tell you what the potential benefit of the project is? How often after you've delivered a product, do they come back and tell you how much money it made or how valuable it was? Yeah, so that's a really good way of working, but it's not typical, I would say. Often the whole benefit-cost trade-off is not made obvious to any of the participants. But the people who give the estimates get in an awful lot of trouble. The people who said what the benefits are going to be are often now VPs in another department by the time the whole thing gets delivered. Of course, they do tell us that they aren't going to hold us to these estimates. So is that what happens? No, it's not. But and I'm not even going to flash up one of those slides which I picked off of a library, a dictionary program off of the web. But estimate, you know, it's in the word. It's an estimate. And so by its very nature, it's a guess. And so you are likely to go one way or the other around it. How far off you're going to be is a different matter. But to hit an estimate dead on is not a sign of any sort of professionalism. One of the things I see is a project will start, especially the long projects that are based on an estimate. We've got a fixed scope, a fixed budget, a fixed deadline, and everything will be going swimmingly for months until generally I would say around 10 to 20% of the budget and time is left. And at that point, that's when problems start emerging and projects go into amber. And then they go and start negotiating scope reductions. They start negotiating extensions on delivery, stage delivery, dropping quality controls. And this goes on. And so one of the things we have to watch out for is people using our estimates to then beat us around to drop, to deliver shoddy stuff, and then to try and use it to aid their negotiations to get more budget later on. The 90% done story happens a lot. You're always 90% done. You could be 90% done for, you know, weeks, if not months. The zero defects promise, on time, on budget, every project. Well, would you say that your organization is on time, on budget with every project?
Most of the time, but it costs a lot to
So I think to paraphrase, you said that you do generally do on time, on budget, but actually that estimating procedure is quite expensive. Is that what? Right. So this is a classic one. It's working in the test environment. So I'm sure you've all seen that. And finally, of course, integration. That won't take any time. So when you start cutting a project, when you're green, when you've got an estimate, you've got a deadline, you've committed to it as far as people are concerned, you're working towards it, the things that get scrimped, the things that get squeezed are the bits that happen at the end. Because developers are developing away. So it's tests that get squeezed, it's integrations that get squeezed, it's the final finishing touches that get squeezed. And these are all bad things for our customers. So why do we carry on doing this? Because if you were to follow, I don't know if you were at the keynote yesterday, but if you were to follow some of the agile principles that Alan was talking about, where you're going for interactions over a plan, trying to focus on delivering customer value on a regular basis, then you'd be delivering small increments of finished product all the time. And when you either ran out of time or ran out of budget, well, then they would see what they had. And that seems like a reasonable way to go, because at least they get something out of it. Whereas in this way, you quite often see failed projects. So I don't know if you looked at Capers-Jones's research or empirical gathering of information, but he reckons that somewhere between 50 and 60% of projects fail. And this was gathered over the past 15 years, and it's still true today. It's not an ancient, archaic thing. And of the 40% of projects that don't fail, most of them have been delivered over budget, not on time, and with scope cut. So the definition of success itself is, did it get out in front of the customer? Not, did all of it get out in the way that you promised and delivered the value that the customer wanted? So I'm going to bring out another quote. So Niels Bohr was a proper scientist, and he had some very wise things to say about prediction. And that's what they are thinking that we're doing. We are making a prediction about when something's going to be ready, how much it's going to cost. But it's a tricky business because, as you'll know yourself, until you get into doing something, you don't know how long it's going to take. So how long is it going to take to clean out that drawer in the utility cupboard that you've just been stuffing stuff in for the past 3 years? Well, it shouldn't take very long. So one way you can do it is just tip it into the bin and be done with it. But if you need to sort things out, you suddenly find that it takes more time than you thought. You might say it'll only take half an hour to paint that fence, and it takes you 2 days. And you run out of paint halfway through, and you go to the shop, and they haven't got the color to match. And I hope you see where I'm going, that until you really get into the details of the problem, it's very difficult to know actually what it entails. And this is why I believe that your predictions are probably quite good. And it's something that someone said to me last night. She said when she needed to do a really detailed prediction for something that she thought was going to take somewhere between a month and 6 months, she asked for 2 weeks to do the estimate. And she went in and then actually coded up and worked on the hardest bit, the bit that she thought was going to be the hardest bit in that 2 weeks. And at the end of the 2 weeks, she was able to say, I think it'll take between 2 and 3 months. And she felt confident about that because she had actually gone down in, decomposed the problem, decided how one approach that she might be able to solve it, did a few spikes, did a bit of work in that complex technical domain, and came up with an understanding of what work was involved, and that put her in a really good place for making an estimate. I don't know about you, but that's not typically how estimation is done. You have a very short amount of time, you sit down with a very sketchy requirements document, and you do some big block diagrams, a bit of top-down decomposition, put some numbers together, and then add them up in Excel. And you'll probably put it in Excel and play around with the numbers and wait for that number at the bottom to be sort of all right. So you'll start off by thinking, what number here will my manager accept? So has anyone ever given people an estimate and said, they've asked you, could you please estimate me how long it's going to take to deliver X? And you go, it's going to take this amount of time. And they go, that's too long. I'm sorry, that was my estimate. What do you want me to do? Well, give me a smaller number. Okay, here's a smaller number. But this is the process. This is the sort of the level of engagement that we have to battle with. Now, a lot has been said about estimation over the years. And when I got interested in it maybe half a dozen years ago, I went out and bought this book. Now, it's not a great contrast on the screen. It's by Steve McConnell, who may be familiar to the developers among you, who did Code Complete 2, Rapid Application Development. You know, he's a well-grounded, Microsoft-centric developer type. And he went off and was interested enough to do this book on estimation. Now, it's a big book. So this is a two-dimensional picture. There's a third dimension, and it's quite deep. And there's a lot of stuff in estimation, and a lot of it is quite number crunchy. It's about plumbing historical data, doing analysis of your projects, your failures, how long things took, how the variance from predicted to actual delivery times. This is not something that I have seen in the companies that I've worked in. To give you a flavor of what he says, Steve says, the primary purpose of an estimate is not to predict. So it's to give something that's realistic enough to allow the project to be controlled. Now, what we're saying here is that that estimate is something that gives you a starting point for thinking about how it might compare to other things that you're estimating. It certainly can't tell you how much it's going to cost. People can tell you later how much they can afford to spend, and you can spend that, and you can control it in a way that will deliver them the best value for that budget. If they tell you that they want it for a particular time, then you can tell them how much you think you'll be able to fit in given the resources that you have at your disposal. So, I mean, I don't have a slide of it, but are you aware of the iron triangle? Which is a management meme, which has got three sides, which is resources, time, and scope. And basically, the saying goes, you can fix any two of them, but the third one has to be variable, because we just don't know enough to be able to promise all three. And that itself was then, to some extent, debunked by Fred Brooks a whole 30 years ago in his Mythical Man Month book, where he said, and I'm going to paraphrase here because I haven't got the quote, but one thing to do to make a late project later is add more people to it. And yet that is almost invariably the response of every organization I've ever worked with that have had a fixed deadline. So they go, fixed deadline, fixed scope, got to get there. Tell you what, that third axis will just pump in a whole bundle of contractors. It was so bad at one place that they were hiring contractors. They couldn't, it was back in the dot-com boom, and it was Java, and they couldn't get enough Java developers at any price in the UK. So they were flying them in from the US for 6 weeks, right, onto a project that had no obvious documentation or design. And they would sit down, they would just about have their login, and they would go home again. That did not speed up the project. So, diversion over. So this is the table of contents of part 2 of Steve McConnell's book. And as you can see, there's a lot of different approaches that he researched into estimation. And a lot of them, if you read them, they make sense. You know, yes, we could possibly do something like that. And I've talked a little bit about things that you might think characterized as estimation by analogy. I'm sure you guys yourselves have been asked to do individual expert judgment. Quite a lot of us have decomposed things and then tried to add them up again. So one of the warnings actually they put in decomposition and recomposition is that what people forget is that when you decompose things, it does make it easy to estimate. But then when you add them up again, you have to take into account that every small estimate that you've got has its own error bars. And when you add them, you don't just have the same error bars. It compounds itself. So you get a much bigger margin of error. So there are lots of ways of going about it. Most of us don't do most of these. Most of us, I would suggest, are not mining historical data effectively to see how our companies and how our teams actually have performed, and using that as a basis of estimation, gross, large-scale estimation in the future. And yet we carry on doing it. So what's to be done about it? So there's a book, again, another quite long in the tooth book from DeMarco and Lister, who are well-paid, famous consultant types, and it's got a much more interesting title and cover picture than Steve McConnell's book, and it's about managing risk in software projects. So there's a lot of stuff in this book, and its third dimension is a lot thinner than Steve McConnell's. So if you're going to buy one of them or read one of them, this is the one I would recommend. So Steve McConnell's is an interesting tour, an in-depth tour of techniques, but this one is actually useful. So, and I make that distinction on purpose. So it's useful Mainly, and I think my main takeaway that I want to share just now is this picture, right? So this is around estimation. So an estimate is not a number. An estimate is a range and a confidence, a level of confidence. So as a sort of thought experiment for you to try for the next time that you go away and do an estimate, and you see the estimate that you've come up with at the end, and you offer it up to your client or your manager, ask yourself, if I didn't hit this estimate and I was to lose my kidney if I didn't lose this estimate, would I be confident enough to give it to my customer? So that's a very high level of confidence. Someone last night pointed out that he'd had 2 kidneys, so maybe it doesn't matter the first time. So, but nonetheless, that's a high level of confidence. You probably don't need to be that confident. But depending on your organization and what the repercussions are for not hitting your deadlines, you need to understand how confident you need to be. So this diagram basically says, generally, things take longer than you expect. Sometimes they take a little bit less time than you expect, but not by a lot. So that's what that diagram shows. It's based on some empirical data, but it's not, it depends on your organization. Again, this is what you could get by mining your historical data, the curve of how estimates in your organization have played out to actual reality. And what it's saying is, if you're going to give a point estimate, then this would typically be the place you would want to give a point estimate. This is typically not where point estimates come in. When I've worked with developers, the point estimate is normally about here, because the thought process that is going through their heads, and my head and your head is, on a good day, how long would it take? If nothing went wrong, how long would it take? When the last time things went really well, what could I achieve? And so estimates, when they're just a point and you haven't thought about it, are normally very optimistic. We are overconfident about what we can achieve. And this is another reason why you often get the 90% done phenomenon. Because you look at what you've done and think, I've done loads of stuff. That stuff that's left won't take long at all. Until you get there, and it turns out there's loads of stuff there as well. So we're really confident. We're really overconfident. And when do you get asked for an estimate? Do you get asked for an estimate at the end of the project? No. You get asked before you've even started. When do you know the least about the project? At the start. So Steve McConnell, in a different book, put together this diagram. He calls this the cone of uncertainty. And essentially what it says is that early on in the project, you know really little about it, and therefore your estimates are going to vary between 1/4 of what you thought and 4 times of what you thought. So this is a big variance. So if you sat down and you came up with an estimate of 4 weeks, what he's saying is that what you could say to your customer with a high degree of probability is it's going to take somewhere between 1 week and 4 months. Now I think most of your customers will say, well, that's useless. What am I supposed to do with that piece of information? But the fact that it's useless doesn't mean that it isn't true. Now, as it happens, it's not true. This is a thoroughly debunked diagram. Another great book by a guy called Laurent Bossavit, who we'll be hearing more about in a minute, did this book called Leprechauns of Software Engineering, where he takes some of the famous and well-known facts about software engineering and then traces them back to their academic origins and finds out that it's a very flawed scientific process. So the cone of uncertainty, which I showed you, is based on work by Bohm. It's attributed to Barry Bohm back in the 70s. But it turns out that Bohm said no such thing. And in fact, what people have found is that, well, the bad news is that part of this diagram is true. The bad news is that the part of it is true is the top half. Right? Things never take 1/4 of the time you thought they were. In general, it's somewhere between 1/2 or 2/3 and 4 times. So it's not a symmetric cone, because in reality, we are so optimistic, we never overestimate, or very rarely. So this is a great book as well. The other one that he debunks, he debunks 6 different myths in here, but the other one I think is really interesting and wonderful to read is the one about how some software developers are 10 times more productive than other software developers. Again, based on research that didn't ever happen. So my question is, how confident are you? So here's a gentleman who is extremely confident. This is using the wrong tool for the wrong job and thinking that you're going to be okay. And we do a lot of that. So I put that up not because I'm going to draw an analogy, and actually you can't see it very well. That's a shame. So it's a man in a drive-on lawnmower suspended from a crane cutting the top of a hedge. It's a shame. It's a nice photo. Anyway, so we're going to have a game. Who has not got a pen? There's a few not pens. Okay, so could you please take a card and pass the rest of them back? Pens.
Thanks.
Any more pens? So this is a game where I would like you to be confident about the answer. You know, not overly confident, when no one's going to lose a kidney today. Has everybody got a card? Okay, so we'll begin. So there are 10 questions. I'm going to show you a test one first, just as an example. So how many people in this room? Don't count. Think in your head, how many are in the room? And you think of a lower bound and an upper bound. And you should be 90% confident that the actual answer will lie between those two bounds. So my guess, this was a different room. But what do you think? It's probably somewhere between 20 and 40. Would you be 90% confident in that? Don't know. Should we count? No. So that's the form of the questions. They're going to be 10 questions, and they all have numerical answers. I would like you on the card for each question to write two numbers, a lower bound and an upper bound, and you should be around 90% confident that the real answer lies between those two. So, question 1. What was the date of birth of Bram Stoker, the author of Dracula? Like I said, these are questions. You just have to be 90% confident, and they obviously all come from the domain of humanity, or life on this planet. And just in case anyone's thinking of going off to Wikipedia or Google, please don't. Okay, so I'm going to move them quite quickly, give you a chance to think about it. Question 2. What is the population of the Republic of Brazil? Question 3. What is the height in meters of the tallest living redwood tree? I'll accept yards as well. Question 4. How many standardized ISO 6346 steel shipping containers exist in the world? So those are the shipping containers that you see on the back of ships, strangely, and that then get lifted off and put onto lorries. Question 5. How many Boeing 747, all models, just in case you were going to ask, have been built to this date? Question 6. What is the total number of human deaths attributed to H5N1 avian flu? Question 7. How many Syrian conflict refugees were registered by UNHCR at the 1st of November 2012? So that was a while ago. This number would obviously be considerably larger now. Question 8. What was the total wine production of France in 2009 in hectolitres? And just in case it makes any difference, a hectolitre is 10,000 litres. Why did it do that? Oh, it thinks I want to back up. Question 9. How many Olympic medals altogether have been won by the Austrian team? And this does include the Winter Olympics. Okay, and finally, and obviously this one you will all get, what is the half-life in years of plutonium-239? Of all the questions, actually, this is the one that hasn't changed for quite a while. So that was 10 questions, and obviously, you didn't necessarily know all the answers to them. So now what I'm going to do is I'm going to give you the answers. I would like you to mark your questions, and then in the end, I'm going to ask you how many you got. Okay? So no cheating. These are the answers. Bram Stoker was born in 1847. The population of Brazil is around 199 million. The tallest living redwood tree is 115 meters, about 120 yards. There are 20 million, approximately, ISO 386 standardized shipping containers in the world. 1,486 Boeing 747s have been made. 379 people have died from H5N1 avian flu, or at least have been registered as died by that. 2012, there were 286,000 Syrian refugees registered with the UNHCR. 45 million hectolitres of wine were produced by France in 2009. There are 304 Olympic medals that have been run by the Olympic team. And the half-life of plutonium-239 is 24,000 years. So, I'm now going to walk out of the view of the camera and ask you for your answers. So, how many people got none right? 1, 2. Is it just 2? 3. So could you do that again? How many people got none right? 3. Okay. How many people got 1 right? 1, 2. How many people got 2 right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. How many people got 3 right? 1, 2, 3. How many people got 4 right? 1, 2, 3, 4, 5, 6. How many people got 6 right? 1, 2, 3, 4, 5. Am I on 5? Oh, sorry. How many people got 5 right? Let's start there. 1. Okay, sorry. How many people got 6 right? 1, 2, 3, 4. Something went wrong there. How many people got 7 right? 1 at the back. How many people got 8 right? 9. 1. Excellent. 10. Okay. So a little bit of maths. If you had been 90% confident, and I asked you 10 questions, and you were 90% confident about each of the answers, on average, how many should you have got right? 9. So this is clearly just a bit of diversion in the middle of a session, but equally it's to try and show you that we're all overconfident. So it's not, I wasn't even trying to hide from you at the beginning that I wanted 90% confidence. So I would have been perfectly happy if you put 0 and 100 million for every answer and just got one of them wrong by putting 1 and 1. And you would still have been 90% right. But you self-policed into thinking he wants to have a small range, the smallest possible range. And that's what you did. But you didn't apply the 90% confidence, or if you did, then you're very overconfident. So the point here is that actually this is something that I see over and over again. And this comes back to the graph, the distribution I was saying, and how developers typically put their estimate at the very optimistic end. And I see this over and over again. People self-police themselves. And it's not just an estimation. So I do a lot of working with teams whose managers have paid for me to come in to try and help them improve their unit testing and their test-driven development, test-driven design. And when I speak to those people, when I go back a few weeks later and find that actually things haven't changed very much, I get very personally upset because I think, have I not been able to convey any information effectively? But what they tell me is, no, well, it would just take too long. Our managers won't let us do that. Yeah, it was the managers that asked me to go in And when I speak to the manager, they go, no, we really want them to write tests. We want quality code because otherwise it keeps breaking every time we do a change. But the development team self-polices. They apply the pressure on themselves because they think somebody else wants things to be done quicker. And when we estimate, we think people want a small price. They want a small range, and they want it to be as small a number as possible. And this plays into a space that other people, Dave Snowden and others who we'll talk about later, have been working, where there are three things that, if you're asked a question, you can either know the answer, not know the answer, or be uncertain about the answer. And in sociological experiments have shown that people would far prefer to be wrong than uncertain. And if there's any message that I think is worth thinking about later, maybe it's better to accept and express the fact that we're uncertain rather than being wrong. So it's great to be right. If you're certain about something, go for it. But if you're not certain, then let's say, I don't know, and look into it, and then when you are certain, you give an answer. But don't immediately plump for an answer just because it makes you feel better to have an answer. So we've done that. Poolrook said, we aren't really bad at estimating. And I think this comes to the heart of the problem. So the overconfidence is we can't really sit there and think through all of the assumptions that we would need to understand to make a good estimate. So here we are. I've been talking for 40 minutes odd, and we've played a bit of a game, and we've thought about estimates, and I hope, I don't want you to think that I hate estimates, but I just can't see how they can be good unless we're prepared to invest in them. And so given that most of us don't and aren't permitted or encouraged to invest, significant amounts of time in estimating, why do we do it? So if we go back to sort of building or analysis of an analogy with building, let's say, something like a shelf which has got wood on it, you estimate, and then you would measure the space, and then you would measure it on the wood, and then you would measure it in the space again. And that's led to an aphorism, or at least a tried and trusted piece of advice in joinery land, which is you measure twice and you cut once. Because once you've cut, well, you can stick wood back together again, but it's not easy. It's not the same in software. We don't do that. We don't measure twice. We often don't measure once. We do this estimating where we slightly decompose things. We're not sure of all the requirements. The requirements are bound to change. We use whatever heuristics we have in our organization of, think of a number, double it, add 5. There's a lot of work around budgeting, because a lot of the issues that we talked about and that you brought up at the beginning of this session were around how do our customers, how do our business leaders know where to make the investment? How do they know how much money they're going to have to spend? And so this comes down to budgeting. And again, there's a discrepancy, or at least a divergence between how one behaves and the behavior you see in internal IT organizations and in companies that are doing quotes externally to get business. So the internal ones are much more, shall I say, dysfunctional. So I don't, raise your hands if it doesn't work like this in your organization. But typically, budgeting happens once a year. There's probably a program office that manages. No, it doesn't work with you? What happens with you?
We have a weekly, if you're talking about internal resources,
yeah.
we have a weekly resourcing meeting.
Uh-huh.
But then we talk to clients, we don't do internal meetings.
So that's asking where you're going to put those resources, but not how many resources are going to be committed to a given project for. Okay, fair enough. So I mean, that's an interesting way of working. I guess you're probably the sort of well, maybe not, but you're a company that could certainly do the. I've started the work, but now we've got this high-profile client, and we'll be back to finish your job when we've done with them, because your weekly meeting could move all your resources across to somebody else's work. It doesn't work like that. Okay, go work for this guy. Yeah, fair enough. So, but in large internal IT organizations, banks, insurance companies, there's often an annual budgeting process. The budgeting process itself takes managers and middle managers 6 months of time. They spend a lot of time doing it. it's all entirely fictional, but they fix amounts of money that goes to particular departments, and from that they cherry pick bits of program work, and they then use estimates to try and see which bits they can fit in. And it's beyond dysfunctional. So there was an insurance company that I was working with a couple of years ago. They sent all their developers on I can't even remember, was it a Struts 3 training course, and they were currently running on Struts 2, but they were going to upgrade, and they had a project to do, and they had an upgrade project. They decided they couldn't afford to do the upgrade project, so all the Struts 3 trained developers were then told to implement the project in Struts 2. So they wasted the training, pointless. They then implemented something on an out-of-date platform that they were then going to have to migrate when they migrated up to Struts 3. And that's the sort of dysfunctional behavior that you can get out of a budgeting process that is purely focused on trying to fit numbers in within a portfolio. And there is a movement called Beyond Budgeting, which has been going, that started off in Scandinavia and has been successfully implemented in a number of banks over the past decade and a half. And a gentleman called Bjarti Bogsnes, who works for Statoil, is in the middle of rolling it out in that organization, which is a much larger business. So that's probably above our pay grade. So one of the reasons people still want us to do estimation is so that they can forecast when's it going to be ready, how much is it going to cost. It's for resource allocation, it's for prioritization, it makes things visible. We can also use it for tracking, so how much money did we spend, how much money did we get back from it, was that project worthwhile, is it beneficial, can we learn anything from it? Unfortunately, it's still an estimate. You know, people want these estimates, but quite often they do get cast in stone, and we get stuck there, and we get forced upon us. They get forced upon us. And I think part of the problem here is that we are giving them that date, that one number with no confidence ranges. And as long as we continue doing that, no matter what people tell you, they will continue taking them as not just estimates, but actual commitments to deliver to a particular point. And there is an interesting decomposition that goes through the business, because the estimates for this forecasting and project prioritization are often these large gross estimates that are done at the beginning of a project. They're done from the outside before you know the full requirements. And then as the project kicks off, once it's been initiated, you've been allocated the resources and they form the teams and you start working on it, you begin to break it down. You do some form of decomposition, you do some sort of planning of what's going to be released, and then you do other estimates within the actual development life cycle. And those estimates are more for the project manager to see, are we on track? Is there any way that we're ever going to meet the commitments that we've already made on the outside? So we do have different levels of estimates, and we'll cover that in just a second. But the bit that I really, I don't want to move away from just yet is about how different parts of our organization treat estimates in a different way. And I was struggling for a long time with how to think about this. So I was in a session here before lunch, and Dino was talking about bounded context in domain-driven design. And that's interesting because I saw something similar a year or so ago from a Jeff Patton discussion, and he was talking about boundary objects. And it was just so clear. Estimates are boundary objects, and boundary objects are something that come from sociological research again, and they're things that mean different things to different people. So, I mean, Wikipedia obviously is not the final source of all sociological truth, but this definition I think is probably a good one. So, it's information that is used in different ways by different communities. So the way the development community uses an estimate is very different from the way a business community uses an estimate. And this is plastic. So they have to, the intent is that they move across and everyone gets the same information from them. The reality is different. And it goes on, well, this is actually from Lee and Griesner, who are proper sociologists, not just Wikipedia sociologists. So weakly structured in common use. And so an estimate, it'll take 2 weeks. That's a very weak estimate. It basically means it's going to take somewhere between a week and 3 weeks probably, or a week and 5 weeks. It's 2 weeks, something like that. I'll be there on Friday. But they become more strongly structured. They have different meanings in different worlds, but you need to have some means of translation. And this is key. So the creation and management is key in developing and maintaining coherence. So the fact that basically what happens with our estimates is we prepare them with one mindset, and then they get moved across through the organization and treated by quite a lot of different layers often until they reach a different audience with a different set of experiences and a different set of expectations. And that's how the problems really creep in. So you come up with an estimate, and you may not realize it, but your project manager may combine that with other estimates and do some sums and possibly fiddle around with end dates and resources. Then someone else is going to do some manipulation on those numbers, and then it makes it up to the program office where they stick it into a spreadsheet. They have no idea what's going on underneath all those line items. It's just a gross number. And it's this translation that has been causing problems. So where did this all come from? This is the original Waterfall paper. So it's 1967, I think, 1970. So Winston Royce did a paper on a new way of developing software. And it was misunderstood. So this diagram is on page 2. There's another diagram on page 1 which only has the downward arrows. And that's why it got called Waterfall. So Winston Royce didn't call it Waterfall. So this is, Winston Royce was saying when he first proposed it, that at each stage of and that requirements gathering, analysis, design, implementation, and testing, you should feed back to the level above, because that's the way you learn. But that didn't typically happen. And what we did ask for is we said, well, let's estimate it right up here in system requirements, and that flowed down, and those estimates had to stick. And then back in the 90s, people started going, well, maybe there are better ways, more flexible ways of delivering things. And that's when this Agile Manifesto, 2000, the Agile Manifesto came into existence. And, it talks about, it says it here. It talks mainly about collaboration over contract, working software, individuals over processes and tools. But are we still estimating? Yeah. Has agility, have agile teams stopped doing estimates? How many software delivery companies enter into an agile contract with their customers, where they say, you give us some money, we'll deliver some functionality, we'll do our best to deliver as much as we can, you've got to trust us on this. After we've delivered that first little tranche, if you like it, we'll deliver another little tranche. There are very few like that. There are some people here today, maybe not in this room, but I was speaking to a gentleman earlier who works for a company that does exactly like that. But most customers won't wash it at the moment. And so we're still doing these estimates. So we've got estimates coming in. The Agile way of working asks us to talk about user stories. So I guess at this point I should find out, get a flavor from the room. How many of you work in an Agile or Agile-ish environment? A few. Okay. Do you use user stories? So this is a user story card from J.B. Rainsberger. And JB is very strong on the old XP definition of a user story, and that is that a user story is a placeholder for a conversation. So it's not a requirement, it's not something that on its own can be estimated as such, but maybe you can do something with it. But it's definitely trying to identify some work that needs to be done, and you delay it until the last responsible moment. And by that way, you try and avoid waste. So you don't do work on things that you might not reach. You don't try and get all the full final details about things that may never be implemented. And it may never be implemented because we don't know if we've got enough budget to deliver it. However, what's happened over the past 15 years is that XP has been less popular, and Scrum is an agile method that's become very popular. And one of the things that got popularized by Scrum is something called planning poker. Now, planning poker did come from XP, but it's become a bit of a cult within the Scrum community. And what you do is the idea behind story points is they have no value, actually, so it's not a day or an ideal day or an hour, but you pick a task, a story that your team has already implemented, and you use that as a baseline. That this is the simplest story you'll ever implement, and you say that's a one-pointer. And then every time another story comes up, as a team, you compare that story to the story that you've baselined as a one-pointer, and you vote. The team votes. They explain what the story consists of, and they all pull out a card, and the person who has the highest card explains why he thinks it's so many times harder than the baseline story, and the person who has the lowest card explains why he's reached his opinion, and then everyone votes again. And so it's very democratic, it's very consensual, and it leads to numbers. And there's a theory behind this. And I'm going to challenge that theory. So we're going to play another game. It's slightly less active. It's called the How Long is a Piece of String game. So yes.
It's twice the length of 1 inch.
Excellent. So I got that answer last night. And so last night I thought I must do a slide where I have that answer and I have, again, the QI klaxon going. But I didn't have time, unfortunately. So yes. So let's not say how long it is. Let's just do some relative estimation. So which piece of string is longest? We've got a C, we've got a B.
We missed some part of E. Because it goes around the entire.
So there's the first problem, okay? We don't know. We have no way of knowing which one is the longest because E disappears behind it. And now, obviously it's a joke, but the reason that's there is because when you're dealing with large things, often you don't see parts of them when you start looking at them. So actually E is the longest. So let's discount E. What is the second longest? So we can start again. We've got a C, D. Is this easy? No. So this is just a piece of string. So the point I'm putting up here, the reason I'm showing these pieces of string is not because I have a particular fetish for coloured string, although it was quite fun gluing them onto cards. I haven't done that for a while. E is the longest, D is the next longest, C is the next longest, A then comes after that, and then there's B. So actually they're quite big differences. So E we can discount because you couldn't see it. That was the trick question. But you know, but the difference between 100 centimeters and 70 centimeters is quite a lot, and yet here we are. We spend our time, you know, we've spent our entire lives judging distances and sizes and how near is that bus about to run me over, you know, and yet with such a gross difference, it's still difficult to compare and come up with an accurate comparison. And although it's just an analogy, my submission here is that this analogy holds with software. The things that we're trying to compare are large, and it's difficult to compare them in any meaningful way. The Agile Alliance online, so the Agile Alliance, I don't know if you know this, the Agile community, the Scrum community, has got Scrum Org and I think the Agile Alliance, and there've been disagreements anyway over the past. But anyway, this particular one have said that the research shows that people are better at relative than absolute estimation, but they haven't found any evidence, you know, empirically that backs it up. So there have been small-scale studies done, but we in the community who've been doing this story pointing now for 15 years haven't demonstrated that that is the case, at least not in software. They go on to say that it's not true, it's just that it's not proven. So I showed you some fairly large pieces of string and asked you to compare them. And let's ignore E because that was a trick. What about these ones? Which is the longest piece of string here? E, next. D, next. Yeah. So it's the same order of magnitudes, you know, as in I've just done them a tenth of the length of the original one, of the longer ones, and yet it's much more easy to compare. Again, it's just an analogy. So, but here is where I'm going, that it becomes much easier to do any form of estimation on something that's small, where it can all fit inside our tiny little heads at once, than trying to do comparisons of big things. And so, you know, I've quoted from a lot of the great and the good, the people that I respect in the world, and so now I think it's time to quote from Father Ted, who is obviously an expert in this field. And the point here is that things that you haven't done yet seem smaller than they actually are, almost always. Now, there is the counter-argument that says sometimes you don't want to do something because you're frightened about it, and when you actually get around to doing it, it's not as hard as you thought. But in general, it's the things that are far away that you go, we'll probably be able to do it in 3 months. And you might mean 2 months and you might mean 8 months. But the things that you have to do tomorrow, when you've broken them down to smaller things, into smaller stories, then it becomes more amenable for you to try and decide how long it's going to take, because you can actually think on the task-based level. You've thought about the requirements. You've maybe spoken to your test team about what tests you would run. what tests they would want to run to ensure that it worked. You've spoken to your product owner or your customer and said, ask them, what is it we need to deliver to the customer? How are they going to respond to it? Why are we doing like this? So although this is not specifically, this isn't about Agile as such, Agile lends itself, at least the Agile way of working, where you base things on stories, where you deal with large-scale epics and you break them down to features, and then when you get close to having some time to work on that feature or it becomes a high priority, you then break that down into smaller stories, and you keep on working and breaking it down until you get to something that is extremely small. And so for me, at the core of doing the in-process within the software development lifecycle, the core of getting good estimation, which you can use for tracking to give some sort of idea of how much scope am I going to finish in the next week, in the next fortnight, in the next month, is having small stories. So for those of you who don't work in an iterative Agile environment, or even in any environment that uses small deliverables that get incrementally delivered, iteratively delivered quickly, I'm talking here about stories that can be delivered from start to finish in something like 1 to 3 days, under a week. And that means that your test team has a constant flow of things going to them. Your development team have constantly pulling new pieces of functionality or new stories off of the backlog and discussing them with their customer or their product owner. And the whole thing keeps on moving. And you don't get the situation which I see time and time again, which is one big story stuck in the to-do column or being worked on for a week, 3 weeks, 3 months, and it's always 90% done, and it's really difficult to get a handle on what's happening. And this is all about giving our customers some way of knowing what's going on, because if we flip back through all of the large macro discussion about why is it that estimates are still required, even though we've demonstrated for thousands of years that they don't really work, it's because they don't trust us. And the idea is that we haven't given our customers, our management, any way of understanding how things are going, except from the delivered product at the end that gets in front of the customer. And because they don't know how things are going, they have to try and exercise due diligence before. And so they use old methodologies and old ways of trying to keep us on track. So this is a slide that you can't possibly read. It's here because it's for anyone who struggles with trying to make stories small enough to fit in 1 to 3 days. Richard Lawrence has put together this slide of heuristics and approaches for splitting user stories. It's on the Agile for All website. This talk is already on SlideShare, and it will be on the Software Architect website as well. And so we have all the links on the bottom of the slides too. So the first thing I try and do in my teams when we're in delivery and development mode is to get the stories, the increments really small. And once we get them small, we can start doing some story planning, some story mapping, which is a technique that was introduced by Jeff Patton, again, a decade and a bit ago. And this is where you actually start thinking about trying to deliver little bits from across the application. Because another thing that I see people failing at a lot is that we've got 4 different bits of functionality that we need to develop. Tell you what, we'll do all of piece number 1. We'll do 2, 3, and 4 later. And I find that incredibly frustrating, because almost inevitably your customer needs something out of all 4 of those pieces of functionality to do anything useful. But in reality, no matter what your PO, your customer, your business-facing person is telling you, they probably don't need all of each of those features to do something useful. They might need all of it eventually to do everything they want, but they probably only need a little bit. And the thing about breaking down your stories into small vertical slices that can be delivered independently, incrementally, is that you can then start moving them around, and you can begin to get a journey, a customer journey, through the whole application, even if it's not fully featured, not fully functional. And that means that you can start getting feedback back from your customer about the actual customer flow. You can start getting your UX people involved. You can actually start de-risking some of the things that, even once you've successfully delivered the software, can still kill the product. So on this case, I haven't actually got a slide of it, but Jeff Patton has actually just released his first book on the subject. It came out last week. But anyway, how do you decide which bits to do? So there's always the stuff that the customer needs first, what the customer wants. But there are also the things that you as a development organization, the architects, the developers, the testers, understand are risky. There are always going to be risks. And so again, out of Waltzing with Bears, that's from their introduction. It says, if there's no risk to your project, don't do it. And so this is to remind us that what we're doing is trying to deliver value. If there was no risk there, it wouldn't be worth doing. It would already have been done, or we wouldn't need to do it. So there will be risk because you'll be doing something that your company hasn't done before, or hasn't been done in your organization, or you haven't done before. So, no politics. Does anyone remember who this guy is? Donald Rumsfeld, sorry, I just want to... Yeah, so it's Donald Rumsfeld, and he's famous for saying, there are known knowns, there are known unknowns, and there are unknown unknowns. And when he said this, the press had a field day. They said, what an idiot. But actually, it makes perfect sense. So this is the stuff, when we go into a project, we know about this. So this is maybe this is the programming language that we worked with. Maybe this is the domain. We know something about that, the libraries that we're going to work with. We know maybe about our internal architecture, and we know about the service buses or the databases or the persistent lists. There's stuff that we know. We can go, yes, it's going to be like that. Then there are known unknowns. These are the things that end up on your risks and issues logs. These are the things that you don't quite know about yet. It's maybe the new technology. It's maybe you need another component, or it's an area of business that you haven't yet implemented anything in. And all of these things are what we handle on a day-to-day basis. It's the tools that we use, and it's the way we manage and mitigate risks within our organization. This is the stuff that destroys a project. These are the things that come out of nowhere. And it's easy to go, well, they're unknown unknowns. We can't do anything about this. But the reality is that if you put the right people together in a room and actually talk through a problem, quite a lot of these unknown unknowns move into known unknowns. Because when you start asking questions, people who don't know about a particular area ask questions that you weren't expecting. This is, it was popularized in some New York Times bestseller book. I can't remember what it's called, but it's known as the wisdom of crowds. So, and this is, if you get enough people with different backgrounds together, you will get better answers than if you ask them all individually. And the same works in a software development project. So this is at the core of a method that I use with my customers, which is called behavior-driven development, that you might have heard Alan talking about yesterday. And the core of that is we put, at the very minimum, a tester, a developer, and a business or customer person together in a room and get them to talk over those stories. Because when they ask each other about how that story is actually going to work, and using concrete examples of data coming in, user actions, states of the system, how is it going to behave, we quickly find out things. So the message on that one is you've got to assume at the beginning of a project that you're ignorant. Now, that doesn't mean you're stupid. It just means you don't know everything. And this is a great piece of humility that you can take into things that help counter the overconfidence that is incipient in all of us. And that meeting, the Three Amigos meeting, the meeting of the developer and the tester and the customer, is again called deliberate discovery. So it's the wisdom of the crowd. It's going in saying, we are ignorant, we're going to really challenge our assumptions about this to try and find out if anyone in the room can ask a question that we don't have an answer to. So here, this is Dan North, who's a London-based consultant who's been working in this field for a long time. And so it's when we start a project that we're most ignorant, but we need to make the best use of the time, and we need to identify and reduce our ignorance. And we aren't going to do that by reading a requirement document and saying, yeah, that sort of makes sense. And that's typically what you do with a requirements document. You go, yeah, okay, I can't see any errors here. The trouble is we don't see errors until we challenge them, because the semantics make sense. You actually have to work through how it hangs together before you find out that it doesn't hang together, or there are corner cases, or there are bits that are broken. Equally, Tom Gilb, who created the Evo method in the 90s, way before Agile was called Agile, he's done insane amounts of work with requirements. And his rule of thumb, empirical evidence from the research he's done on his subset, is that if you take an A4 page of requirements, and he's dealt with banks and space agencies and the like, an A4 page of requirements sampled at random has around 50 errors in it. Now, I still can't believe that. but he's consistently shown that, and he's got more data than you can ever possibly plow through. It still seems wrong, but even if he was out by an order of magnitude, and there are 5 errors on every A4 page of paper, that's still worth trying to challenge, because by the time you've developed it, it's too late. So one way of dealing with this on the outside, so basically what I'm saying is estimation is hard. Estimation is hardest when we know least about it, which is when we're asked to estimate big things so that people can make budgetary decisions. So let's start off by having another way of looking at things. So we break them down into features, and this is from Liz Keogh, and she talks about complexity. And she has 5 different levels of complexity where you think about the actual sort of bits of the system that you're being asked to deliver. And you just basically do a gross look at it and go, how complex is this? And so the simple things, number 1, everybody's done. Number 5, nobody's ever done this before. So this is probably going to, whatever estimate you come up with here is going to be a huge wide bar because you've no idea how long it's going to take. Whereas things up in this area, maybe you can do quite an accurate estimate of it. So this is a it's fairly straightforward and sensible, but again, it's something that until someone says it, I hadn't really thought about it like that. So you can start doing complexity estimation and base some of your analysis and some of the recommendations that you feed back up through the company on that. There's also another model called the Knevin model. Dave Snowden does this, and it looks like Sinofin, but it's Welsh. I don't know. Have we got any Welsh speakers in the room? Okay, then I can just say Knevin. And again, he thinks of the world in these segments. And down when you're working in simple things, you can use best practice. So what we're really saying here is that the problems, the things that we need to sort out and solve in the world aren't all the same. And again, that doesn't really, none of you will be surprised about that. But when you're in the simple world, best practice might work. So you go off to Wikipedia, you read .NET design guidelines or a patterns book. Best practice is fine there. When you get a bit more complicated, when you've got interacting layers, then you can do good practice. You can have a look and see, you go to a patterns book, for instance, see how other organizations have solved problems that are similar. But as soon as you get into complex zones where things really interact in, where there's timing involved, where there's lots of different states of different entities and actors interacting in different time streams, then the behavior becomes emergent. You can do the same thing with a system a number of times, and depending on when the database transaction completes, or whether it's at midnight, et cetera, the outcome of that system, the outcome of that action may be different. And in that area, you can't just fall back on simple things. And things that are in the complex domain are going to take more effort. They're going to be more susceptible to risk. Down in chaotic, we don't work here. We don't go here. We end up here by mistake. This is when the server goes down overnight, when a meteorite hits the data center, when everyone dies of Ebola. That's chaos. We don't go there. We don't plan for that, but we have to just handle it. So these are different ways of looking at our problems from the outside without going down and saying it's going to take 3 weeks, but to think we might be able to give you an estimate on that. On this, actually, any estimate we give you is going to be extremely vague. You're going to need to let us spend a lot of time or significant investment if you want us to tell you how long that might take. So let's go back. Why are we doing this? Essentially, all business projects have to do one of 3 things. They have to generate more money for the company, they have to protect the company from someone else who's trying to take their income stream, or they have to save money for the company. So maybe some of you work for not-for-profits, but even in them, you're probably trying to do one of those 3 things. And so before the company can reasonably say, here, have some money to go and do something, they want to be sure that what they're going to pay for you to do is going to achieve one of those 3 goals, or more, maybe 2 of those 3 goals. And so they talk about return on investment. And as I said at the beginning of the session, I don't often see the return on investment being tracked in the same way that estimates are being tracked. They do have nice mathematical formulae, but they don't use them. So there are a number of people working in the field, and I'm afraid I'm going to have to skip through a lot of these quite quickly. I can highly recommend Goiko's impact mapping, which is a way of trying to engage with your business users to deliver an impact map. And essentially, with everything that you're about to, with any project that you're about to kick off, you ask them, why are we doing this project? So this is to actually make your business tell you what the goal of it is. Is it to save money? Is it to make money? Is it to keep customers? And then you go down another level and you say, who could help us deliver it? Who could hinder us from delivering it? Because there are a lot of stakeholders out there that can both be affected by what you do and object or put roadblocks in your path. And then there's what would we actually do with those people to help them come on board or to give make their outcomes better. And finally, there's how would we do that? What are the actual tasks, pieces of functionality that we would like to deliver? Because I don't know, again, I don't know about your environment, but quite often my software teams get given requirements that look very much like solutions. They get told, here's a requirement. And if you ask, why am I doing this? The answer is, well, it's a requirement. No, but why? Well, because it's a requirement. And we go around in that circle. And it's not enough. We have to, our development teams are not just monkeys that turn requirements into code. They need to understand what they're doing because there's a context to these things. I'm not going to dwell on this, actually. Cost of delay is another way of trying to work out which projects to do. Again, it's been pioneered by a London-based guy called Joshua Arnold, and it's around putting a cost on everything. Because actually, one observation that people have made is that you can talk in all sorts of different terms with your business, but until you put dollar signs or pound signs on it, they don't show very much interest. And so what we do is put a cost on everything, and we say we use different techniques to try and work out how much would it cost us if we didn't do this now. And we use that sum to work out what is the thing that would cost us the most by not doing it now and doing that. And so it's an alternative to budgeting. It's a way of prioritizing. Yeah. There's also the no estimates hashtag. I don't know if any of you are Twitter users have come across this. It's been going for about 2 years. It started off by a guy called Woody Zuhl, and a few other people have picked it up. Has anyone heard about that? Yeah? So it's caused an awful lot of heat, an awful lot of disagreement, because it's never good to just say, no, we're not going to do something anymore. The people that pay us, the people that want us to do estimates, get unhappy. And Ron Jeffries went and said that it's not effective or efficient to just say, no, we're not going to do it. This is useless. So we have to make a case. If we want to change the way our systems work, we have to make a case and give people information that will help them understand. It's not that we don't want to do estimates. It's that the estimates are not helpful. They're not helpful to us, and they're not helpful to them. So this plays back to the API issue. So with your traditional software project, the people sitting on the outside, the people who are paying the money, have very little information to go on about how well their money is being spent. And this is where the lack of trust comes in, because whether it's your team or the team that came before you, we have burnt them, right? We have promised things and not delivered. They have paid large amounts of money and projects have failed and disappeared. Whole companies have gone under. So they want to manage us. And the only way they think they can do this is by giving us detailed requirements, telling us that the price, the estimates that they're asking for, they're going to hold us to, and we have to deliver to that. And so they don't really, they really do need to control, because they need to know what's going to go on. They need to have some sort of way of dealing with it, and saying no doesn't help them. So what we need to do is we need to give them some sort of interface through to the teams that help them understand how we're doing. So one of the ways that has become very popular over the past decade is Scrum, because it has fortnightly or weekly sprints, it has burn down charts, it has prioritized backlogs, and people can see how it's doing. It hasn't worked particularly well. But what we still do is we still do these estimates. And we go around this cycle of doing an estimate, doing a project, overrun the time, underdo the scope, overspend the budget. And what do we do then? We do it again. So I don't know if any of you are aware of the Deming cycle, but it's the standard one that's also used by the Army, plan, do, check, act. You go around a cycle of continuous improvement. And if this worked for us, that would be great. But what seems to happen is we screw up a project, they start, and then we have a retrospective or a project post-mortem where we go, how can we do it better next time? We go, oh, we'll do better estimates. And then we do it again. And we just keep going, and we've been doing this for decades. So I'm going to replace this with the observed improvement cycle, where we just keep banging our heads against the wall. And until we or someone else in our organization actually takes it on board, the estimates are at best a very loose guide to our perceived, the perceived size of something, and that they can't be used for anything more detailed unless you really invest in going down to the detailed analysis level. Then we're sunk. And I would suggest that in most of our organizations, that even if we went down to the detailed analysis level, we would still be a little bit in the dumps, because requirements, typically in banking and insurance, requirements change on a regular basis. So the no estimates, I was speaking with Woody Zoll, who started the no estimates hashtag, and he says, maybe it's just a bad hashtag, but he doesn't really mean that we don't do estimates, or he doesn't think that we should do estimates. His idea is that the cycle of giving bad estimates over and over again is a smell that points to other dysfunction in the software in the organization that you're developing for. And rather than saying no estimates, it's let's try and make the estimates either better by working with our organization and investing in those estimates, or let's understand what they're good at and give them in a shape that is true, that isn't overly precise. This was also said by colleague Alan Kelly, who wrote an open letter to customers in general. So he posted this on Agile Connection, and there you go, dear customer. So it's quite a long letter, and so I've just taken excerpts out of it, but it's a very honest letter. It goes, we don't know how long it's going to take, and so we don't know how much it's going to cost. So the gentleman at the back who works for teams that serve customers, how do you cope in your estimation with not knowing how long it's going to take or how long it's going to cost? Oh, he's involved in his laptop. Sorry. Oh, I was just asking a question. Do you know how, when you're doing a quote for a customer, how do you build in any contingency, or do you build in contingency?
Yeah,
a multiplier. So, and that basically wraps up this statement here. We don't know how long it's going to cost, so we're just going to make it bigger. The more details you try to give us beforehand, the more likely you're going to change. So this just happens to be one of those things. As when you ask people, what color do you want it, they'll tell you. But then when they see it on the page, they'll change their mind. Each time you give us more detail, you are offering more hostages to fortune. What this is saying is if you're going to really nail it down, then we are really going to ram those RFCs back through the costing process. And when you want to change, we're going to charge you for them. So the discussion here is about trying to build trust between you and your customer, so that what you say is, we aren't going to sit and drink beer and eat pizza on your money. We will develop the stuff. We will show it to you on a regular basis. You will tell us how much you want to spend, how much you're prepared to risk on us. Once we've spent that, if you're happy with what we delivered, we'll risk the same again. And this is a different model of engagement. It's a model of engagement that follows the Agile way of working, which is through interaction rather than contract negotiation. And then Ron Jeffries finished off with his article on running in the API, saying that actually there's nobody in your organization that actually believes those estimates. They all know it's going to overrun, that it's going to be under-delivered. And actually that's part of the problem. So have you ever had a discussion with people saying, are you sure you really need that? Can we drop it? And at the beginning of the project, no, it's essential. This is not worth doing if you don't do this. By the end of the project, it's, yeah, just deliver. We don't need that. And the reason is because we've been through this cycle, this long cycle, over and over again, and they think that it's going to take 2 years to get a working piece of software. And if they don't get all of their little wants in at the beginning, it's going to be another 4 years before they get them in. And that's another way of sort of turning this on its head. We're delivering things in small increments, and the wonderful thing about small increments is that after each increment, you can change your mind about what you think is most important next. And so if you find that actually this thing that you didn't think was going to make you money is making you more money than you had ever expected, Well, that's fine. We haven't wasted any time on all this other stuff that you said was really important. Not yet. We'll do that. So the things that I would like to you to take away is, I think we really actually need to challenge the use of estimates. So it's not that they're bad, it's just what are they being used for? So we need to understand what they're valuable for. What are they forecasting? How accurate are they? Can people really use them as a basis for planning? We need to make it crystal clear that estimates are estimates. And it's very hard to do that because people will read into them what they will. One of the ways of doing this, to make it crystal clear, is to use the range, to not provide a number, to say, I am 90% certain it's going to fall within this range. Or, I am so uncertain I don't want to, you will need to let me have 2 weeks to do an investigation before I can do this estimate. And again, the further TED, is it small or far away? You know, really, we have to understand that the further away something is, the less we know about it. The detail is just not there. We can't say anything definitive about it. Are there any Java people in the room? No. Any Java people? People working in Java? Yeah, so good. So I can plug the book. This book is now in beta. So it's Cucumber, which is, again, it's about working with your customers and defining acceptance tests and specifications with your customers directly. Thank you very much for your time. I am Seb Rose. Please leave feedback. Feel free to reach out and speak to me on Twitter or by email. I blog on an occasional basis at that website. I have business cards if everybody wants them. And here are some things to read as you walk out of the door. Thank you very much.